Welcome to the Codenteam Podcast, where we connect the dots between investors, tech due diligence experts, and startups. In each episode, we explore the critical insights, challenges, and strategies that drive innovation and success in the tech world.
Whether you're an investor looking for smarter decisions, a startup founder navigating growth, or a due diligence professional assessing the next big thing, this podcast is for you. Let's dive in.
Okay, so imagine this. We're building a skyscraper.
Okay.
But not just any skyscraper. This one has to be super secure.
Right, like Fort Knox levels of security.
Exactly. But instead of steel and concrete, we're using code.
Interesting. So what are our blueprints for this digital fortress?
We've got a stack of articles here all about software security testing, SCA, SAST, DAST, all those fun acronyms.
Sounds like we've got our work cut out for us.
We do. But that's what this deep dive is all about. We're going to decode these acronyms and show you how each one is like a crucial inspection.
I like it, because just like a real skyscraper, software needs those checks and balances at every stage to make sure it's solid.
Exactly. So let's start with something that sounds pretty intense. SCA, software composition analysis.
SCA. It sounds complicated, but it's all about the building blocks.
Okay, break it down for me.
Imagine using like pre-made bricks to build our skyscraper.
Makes sense. More efficient, right?
Exactly. And those bricks, those are like the third-party libraries that developers use all the time.
Third-party libraries, meaning?
Pre-written code modules, like little pieces of code that do specific tasks.
So instead of reinventing the wheel every time, developers can just grab one of these pre-made pieces.
Exactly. Saves a ton of time and effort.
Right, but I'm sensing a but coming here.
Oh, imagine those pre-made bricks. What if some of them are faulty?
Uh-oh, that wouldn't be good for our skyscraper.
Exactly. And that's the risk with third-party libraries. They can contain vulnerabilities.
Vulnerabilities meaning?
Weaknesses in the code that hackers could exploit. And that's where SCA swoops in.
Like a quality control inspector for our code bricks.
You got it. SCA scans those third-party libraries for known weaknesses.
So it's like checking the pedigree of your code's DNA. Making sure those building blocks are legit.
Exactly. And just like a dodgy batch of bricks could spell disaster for a skyscraper, a vulnerable library can put your entire software at risk.
Okay, that makes the stakes pretty clear. Now, you mentioned something about a log4 shell vulnerability a while back. That ring a bell.
That's the one. That was a big one. A vulnerability in a widely used logging library.
Logging library, meaning?
Basically, a tool that helps developers track what's happening in their software.
Got it. So this log4 shell thing is like a faulty brick that ended up in tons of building.
Pretty much. And it led to a lot of scrambling to fix things.
So SCA helps catch those kinds of vulnerabilities before they turn into, well, chaos.
Exactly. It's all about early detection.
That's got to be a relief for developers.
For sure. But here's the thing. Just because SCA flags a dependency doesn't automatically mean we hit the panic button.
Really? I thought a flag from SCA was like a 5-alarm fire.
Not necessarily. It's more like, hey, this could be a problem, but let's take a closer look.
So a flag dependency is like a crack in the foundation.
Yeah.
It might be serious or it might be superficial.
Exactly. Context is key. Developers need to investigate to see if that flagged vulnerability is actually exploitable in their specific software. It's about assessing the risk, not just reacting to every little blip on the radar.
So SCA helps us prioritize which cracks to patch first. That makes sense. So we've talked about checking the building blocks with SCA. What about making sure the blueprints themselves are sound? That's where SAST comes in, right?
You got it. SAST, static application security testing. That's all written.
Okay, so if SCA is checking the bricks, SAST is like having our eagle-eyed architect pore over the blueprints.
Precisely. It's about catching those potential weaknesses in the design phase, which is always easier than trying to fix them after the fact.
Right, because once the skyscraper's built, it's a lot harder to move walls around.
Exactly. And just like our architect would spot a flaw in the design that could make the building unstable, SAST helps developers find and fix security weaknesses early on in the code itself.
So what kinds of things would SAST be looking for? Give me an example.
Sure. Imagine our architect notices that a certain type of window, while aesthetically pleasing, is prone to shattering in high winds.
Oh, no. Not good for a skyscraper.
Exactly. That's the kind of thing SAST helps catch early on, those design flaws or insecure coding practices that could lead to vulnerabilities down the line.
So SAST is all about making sure the design itself is sound before any construction begins.
Exactly. It's about preventing vulnerabilities, not just reacting to them.
Sounds pretty powerful.
Yeah.
Are there any downsides to SAST, though? It sounds almost too good to be true.
Well, like any good tool, SAST has its quirks. One thing to watch out for is false positives.
False positives meaning?
It means SAST might flag something as a vulnerability when it's actually harmless in the context of the code base. It's a bit like that friend who always points out potential problems, even when they're not really there.
I know that type. Well-meaning, but sometimes you just want to tell them to chill out a bit.
Exactly. And that's why it's so important to have skilled security professionals who can interpret the results of SAST and separate the real threats from the false alarms.
So it's not just about running the tool, it's about understanding what it's telling you.
Precisely. You need that human expertise to make sense of the data and prioritize the right fixes.
That makes sense. You don't want to be chasing down phantom vulnerabilities while the real ones slip through the cracks.
Exactly. It's about focusing your efforts where they matter most.
So we've got our building blocks checked with SCA and our blueprints scrutinized with SAST. Are we ready for tenants yet? Or is there more to this software security fortress?
Hold on there. We've checked the bricks and the blueprints, sure, but even the most carefully planned skyscraper needs a final once-over after it's actually built.
Right. You don't want to skip the final inspection, that's for sure.
Exactly. And that's where DAST comes in, dynamic application security testing.
Okay, so if SAST is the architect with their eagle eye on the blueprints, DAST is like sending in the building inspectors once the construction crew is gone.
That's a great way to put it. But DAST is even more interesting than your average building inspection.
Oh, how so?
Because DAST can be either passive or active.
Passive versus active DAST. Sounds intriguing. Tell me more.
All right, so imagine those building inspectors we talked about, passive DAST. That's like those inspectors just walking through the building, observing, jotting down notes, but not like, yanking on doors or anything.
So just looking for obvious flaws, like a door that's been left unlocked or a window that's boarded up but shouldn't be.
Exactly. Passive DAST is great for uncovering those oops moments, vulnerabilities that slip through the cracks during development, but are pretty easy to spot if you know where to look.
Makes sense.
Yeah.
So what about active DAST? That's where things get a little more hands-on.
You could say that. Active DAST, it's kind of like bringing in a team of ethical hackers to test our skyscraper's defenses.
Oh, like those white hat hackers you hear about? The ones who try to break into systems to expose their weaknesses?
Exactly. Except with active DAST, they're not trying to cause any real damage. It's all about simulating real-world attacks in a safe, controlled environment.
So if passive DAST is the inspector doing a walkthrough, active DAST is more like running a fire drill, testing the alarm systems, making sure the sprinklers actually work.
Perfect analogy. Active DAST, it's all about uncovering those vulnerabilities that only reveal themselves when the software is actually up and running.
Like what? Give me an example.
Sure, think about cross-site scripting flaws or SQL injection vulnerabilities, or even those sneaky back doors that a hacker could use to bypass all the security measures.
Okay, yeah, those sound pretty serious. So if active DAST is like the ultimate test, why wouldn't you always go for that approach?
Well, it's potent for sure, but you got to be careful with it. You wouldn't want to test a fire alarm by actually setting a fire in a crowded building, right?
Yeah, I can see how that might cause a bit of panic, to say the least.
Exactly. Active DAST, it needs to be done carefully in a controlled environment like a staging server, so you don't accidentally bring down the whole system just to see if it has vulnerabilities.
Right. The goal is to find the vulnerabilities, not create new ones. So let's say our DAST inspectors, both the passive observers and the active testers, they do their thing and they find something. What happens next?
Well, finding the vulnerabilities is just the first step, right? The real work begins when it's time to actually fix those problems.
So it's like DAST hands you a to-do list, but it's up to the developers to actually do those tasks?
Exactly. Think of it like the inspector slaps a big red X on that faulty balcony. They've done their job by identifying the problem. Now it's up to the engineers to come up with a solution.
Okay, so DAST is not a magic wand. It's more like a really high-powered flashlight that exposes those hidden cracks.
I like that. It's all about giving developers the information they need to fix those vulnerabilities before someone else finds them and exploits them.
Makes sense. But even with all this SCA, SAST, DAST, are we really covering all our bases? Is it even possible to achieve perfect software security?
Well, it's like this. Imagine those inspectors, right? They're doing their best, checking everything they can see.
Right, being super thorough.
Exactly. But they can only see what's on the surface, right? They can't magically peer into every line of code.
So it's like they can tell if a door is unlocked, but they don't know if the lock itself is faulty. and could be picked by a skilled thief.
Exactly. DAST is great at testing the functionality, what happens when I do this aspect of software.
Right, it's like kicking the tires, making sure everything works as expected.
Yeah. But it can't always see those deeper underlying issues in the code itself.
So even with all three, SCA, SAST, DAST, we're still not guaranteed to catch every single vulnerability.
It's true. No single test is foolproof. It's more about using the right combination of tools, get a comprehensive picture of your software security.
So it's like having different specialists on our building inspection team. The electrician, the plumber, the structural engineer, each one bringing their own expertise to the table.
Exactly. And when all those experts work together, you're much more likely to end up with a building that's safe and sound.
That's a great way to put it. But we've talked a lot about tools and techniques. What about the human element in all of this?
Ah, yes. The human factor is absolutely crucial.
Because even with the best tools, it all comes down to the people writing the code in the first place, right?
100%. We can have the most sophisticated security testing tools in the world, but they're only as good as the people using them.
So it's not just about finding vulnerabilities. It's about preventing them from being written in the first place.
Now you're getting it. It's about empowering developers to write secure code from the very beginning.
Right, because you can't just, slap a security system on a building after it's already been built and expect it to be truly secure.
Exactly. Security has to be baked into the design from day one. It's like if you're building a skyscraper, you wouldn't use flimsy materials and just hope for the best, right?
Right. You'd use steel beams, reinforced concrete, the strongest materials you could find.
Exactly. And it's the same with code. You need to use secure coding practices, follow established security standards, and constantly be on the lookout for potential weaknesses.
So how do we actually do that? How do we shift from just reacting to vulnerabilities to actually preventing them?
Well, for starters, education is key. Developers need to be aware of common security risks, secure coding techniques, all that good stuff.
Right. You can't expect someone to build a secure skyscraper if they've never even heard of, load-bearing walls.
Exactly. It's about giving developers the knowledge and the tools they need to write secure code from the ground up.
And probably just as important as the technical skills is fostering that mindset of security consciousness, right? Always be thinking about, how could someone exploit this code, even if it seems really secure at first glance?
You got it. It's about making security everyone's responsibility, not just the security team's problem to solve.
Right, because at the end of the day, a chain is only as strong as its weakest link.
Exactly. When everyone involved in the software development process is thinking about security, you're much more likely to end up with a product that's truly secure from the inside out.
This has been incredibly eye-opening. We've covered a lot of ground today, from dodgy building blocks to ethical hackers, from blueprints to fire drills. It's clear that building secure software is a complex process.
No doubt about it, but it's a fascinating one for sure.
Absolutely. And it's one that's only going to become more important as our world becomes increasingly reliant on software.
Couldn't agree more.
Well, on that note, we'll have to wrap things up for today. But for all you listeners out there, remember, building secure software is a team effort. It takes a combination of the right tools, the right knowledge, and a healthy dose of that human ingenuity.
Hear, hear. And never underestimate the importance of those regular checkups. Just like our skyscraper, software needs ongoing maintenance and updates to stay safe and secure.
Couldn't have said it better myself. So until next time, stay curious, stay secure, and keep those firewalls strong.
Thanks for tuning in to the Codenteam Podcast, where we bridge the gap between investors, tech due diligence experts, and startups. We hope today's insights brought you value and sparked new ideas for your journey.
To stay connected and never miss an episode, head over to Codenteam.com and follow us on YouTube, Spotify, and Apple Podcasts. Until next time, keep innovating and driving tech forward.